Assalamualaikum, my name is Nohidaya binti Shahruddin. This is article is for this task. The title is Burn Area Detections and Mapping using Sentinel-1, Backscatter Coefficient and Thermal Anomalies. For this topic of this article is presenting a burn area mapping algorithm based of change detections of Sentinel-1, backscatter data guided by thermal anomalies. Introduction for this article is fire is one of the natural agents that most alter terrestrial ecosystem and has key ecology role in large part of the Earth's surface. Fire may have to occur to global effect as they reduce soil fertility, change water supply, increase biodiversity loss, and negatively influence carbon sequestration. Fire also alter global biochemical cycle by modifying the emitted greenhouse gas and aerosol present in the atmosphere. Annual global estimate of carbon emission from forest fire is quite variable. They place them between 1.6 and 2.8 pgc per year, which is equivalent to 20% to 30% of the global carbon emission generated by burning fossil fuels. The study area for this article is for developing the algorithm is foresight, which is located at 3 were located at Amazon Basin, 1 were located at Iberian Peninsula. Algorithm relies temporal scales series of ground range detected, dual polarized vertical and vertical horizontal VH polarizations. SAR image acquired by Sentinel-1A or B satellites in interferometric wide SWOT mode. The GRD data was processed on a time-based structure using 100 x 100 km military grid reference system. The Sentinel image from ascending and descending passes from all intersecting orbits are used, and the line cover classification hotspot were derived from thermal anomalies as ancillary data. The hotspot from NASA firm via MO formation for resource management system were recorded by two sensors, which is visible infrared image and radiometer suite, and use a spatial resolution in 375 meter, and the modest sensor distance is 1 kilometer. Landsat 8 optical image were retrieved from USGS as a phrase corrected reflection product. It used as a validation period to adjust its style considering fire seasons and validity of Landsat image. And the study area and the data used image from Sentinel-2 Level 1C were retrieved from Copernicus Open Access to reduce temporal gaps in dataset. The effect of soil on BA detection accuracy were analyzed using global soil moisture at tip passive. L-band radiometer using a 9 km pixel and 3D revisits was used, and the reliability was demonstrated by correlation coefficient above 0.8 between the estimate soil moisture and in situ data measurement. From this, descending past image 6 am in equator crossing is more accurate than descending. This figure shows the location of study area using a military grid reference system TIE. It used for algorithm development and validations. 3 locations are from Amazon Basin and 1 from the Iberian Peninsula. The method used in this article is SAR data pre-processing. The Sentinel-1 data was processed using open source library in Orfeo Toolbox (OTB). OTB-based processing used ground range detected Sentinel-1 image with SAR data being tied to 100 km using MGRS system. This is a figure of pre-processing, geocoding, and temporal filtering. And the second method is calibrate image were auto-rectified to ground geometry using elevation information from the shuttle radar topography mission, 1 second dam, and the big orbit interpolator. And the auto-rectified image were clipped to the processing time and the data acquired from the same orbital path. It should be noted that BA algorithm use temporal backscatter differences of the same relative orbit. The GRD data were processed to the nominal Sentinel-1 resolution 20 meter through the OTB base chains. The BA detection algorithm deployment over large area is conditioned by its performance and accuracy. This is SAR-based algorithm for burn area detection. It consists of 6 stages. First is anomaly change detections, burn and unburned regions of interest, adjustment for temporal decorrelation, random forest burn and urban classification, post-processing, burn area detection without hotspot. This is the result for error matrix for Sentinel-1 burn area detection using for each MGRS type were analyzed. It considers reference periods from 2015 until 2017. This is map of burn area in Amazon basin detected using Sentinel-1 data per MGRS type. Gray is consists of no data, which is maybe from the cloud cover, and black is the formations. Blue is commission, white is for the unburned area, and red is for burn area. This is assessment matrix of Sentinel-1 and MDM4A1 version 6 burn area detection per MGRS style and lane cover classes. The matrix by lane cover will compute using confusion matrix formed by pieces of the same lane cover class from all type. So the conclusion from this article is from the analysis. So the accuracy the proposed algorithm was higher for Sentinel-1 BA detections. The DC value of Sentinel-1 detection per ties are higher than MD-M4A1. The large difference in DC score was mainly caused by the high OE 0.72 to 0.94 in the MD-M4A1 product. Detection of small burn areas is problematic using modest data due to the coarse sensor resolutions. Algorithm accuracy was assessed using the reference burn parameter derived from optical sensor, Landsat A and Sentinel-2. The agreement between the Sentinel-1 algorithm and the reference parameter was compared with that of the most widely used global BA product, the MD-M4A1 version 6. According to analysis of the article is strong topography condition, the BA accuracy with slope oriented away from the sensor being subject to higher errors. Such effects were reduced by combining detection from different relative orbits. Last is scattering from burn areas are directly influenced by vegetation type with higher accuracy being observed over forested area and lower over grassland, which will attribute to the difficulty in tracking change of curb vegetation using C-band data. Lastly, thank you.